Hi everyone, so welcome to my channel. Myself Raza, and in this video I am going to discuss some more important multiple choice questions related to the chapter Secants and Tangents to a Circle of class 10. Right, so this particular video is useful for all competitive exams which are related to the class 10 syllabus, and already I have made a previous video related to this chapter on previously asked questions. Now let us see some more questions here. Question number 1. A tangent PQ at a point P of a circle of radius 5 centimeters meets a line through the center O at point Q, so that OQ is equal to 12 centimeters. Then PQ is equal to. Now let's suppose, so there is a circle, and so he has given, so PQ is the tangent where the tangent meets the circle at a point P. So let this point be, then this is Q, and O is the center of the circle. Then on joining O and Q, so this OQ distance is given as, this OQ distance is given as 12 centimeters. Now at the point of contact, so this will make 90 degrees angle, right? Now he's asking you to find out the length of tangent, and he has given the radius is equal to 5 centimeters. So already we know the formula of length of tangent. So length of tangent is given by square root of d square minus r square. Length of tangent is given by d square minus r square, where L is nothing but length of tangent, d is distance between center and the external point, and r is nothing but radius of the given circle. Now we can remember this formula as a doctor. So dr. Okay, so length of tangent L is given by square root of d square minus r square. Now substituting the values, so what we are going to get, square root of d square is 12 square minus r is 5 square. So which is giving me 144 minus 25. So which is equal to square root of 119. So this particular length PQ is nothing but square root of 119 centimeters. Right, next. If the radius of two concentric circles are 6 centimeters and 10 centimeters, then length of the chord of the larger circle, which is tangent to the smaller circle, is. Now, since he has mentioned concentric circles, so concentric circles means two circles which are having different radius but same center. Now, in this particular situation, so the chord of big circle will act as tangent to the smaller circle. Right, now here you can observe that this is the radius of the smaller circle and this is the radius of the larger circle, so let it be capital R. Now using this concept, so since this is perpendicular, so we can apply Pythagoras theorem, and this part is given by square root of capital R square minus small r square. So whenever you drop a perpendicular, so this will be divided into two equal parts, that is nothing but this perpendicular will bisect the chord. Then this length is also square root of capital R square minus small r square. So from this we can say that this length of chord, so this length of chord is given by 2 times of square root of capital R square minus small r square. So you can simply remember this formula. So which is nothing but given by 2 into capital R square is 10 square minus small r square is 6 square. So 2 into square root of 10 square is 100 minus 6 square is 36. So which gives me 2 into square root of 64, which is equal to 2 into 8, which is equal to 16 centimeters. Hence the answer is 16 centimeters. Right? So you can remember this formula. The length of the chord is given such that, so it acts as chord for the smaller, so chord for the bigger circle and tangent for the smaller circle. Right, next moving on to question number 3. The number of parallel tangents to a circle with a given tangent is. So if a tangent is given, so for a circle if a tangent is given, so to this particular tangent we can draw only one parallel tangent. So answer is 1. Next, the length of the tangents from a point A to the circle of radius 3 is 4 centimeters. He has given the length of tangent. So length of tangent is 4 centimeters, and here he has given radius of the circle is 3 centimeters. So radius is 3 centimeters. Now what is he asking? Then the distance between A and the center of the circle. So he is asking you to find out the value of D. So D is equal to question mark. Now already we know L square is equal to d square minus r square. L square is equal to d square minus r square. So from this, I can write d square is equal to L square plus r square. Now substituting the values, so this is 4 square plus this is 3 square. So clearly 16 plus 9, which is equal to 25, which is equal to 5 square. Now from this, d is equal to 5 centimeters. Hence the distance is 5 centimeters. Right. Next, moving on to question number 5. The length of tangent drawn from an exterior point is 8 centimeters away from the center of the circle of radius 6 centimeters is. So what is he asking? So length of tangent is asking, right? So length of tangent drawn from an exterior point is 8 centimeters away from the center of the circle with radius r. Now he's asking you to find out the length of tangent. So if length of tangent is L. Now what are the things that are given? Distance is given as 8 centimeters and radius is given as 6 centimeters. So from this, L can be written as root over d square minus r square. So when you substitute the values, so this is 8 square minus 6 square, right? So from this, what I am going to have? So 8 square is 64 minus 6 square is 36. So what I am going to get? Square root of 14 minus 6 is 8. Next, 5 minus 3 is 2. So length of tangent is root 28 here. So root 28 can be written as 2 root 7 centimeters. So if this is the question, then the answer would be 2 root 7 centimeters. Now here, basing on the options, so this question is not what he is wanting, right? So by using this particular thing, so whatever the information that he has given, so based on that we are going to get this answer. So amongst these options, if you want to get the answer, then you need to change some things. So what is that? So the length of the tangent is 8 centimeters. He has to give. He has to give length of tangent is equal to 8 centimeters, and he should ask the distance between center and the exterior point. Then we can say square root of 8 square plus 6 square. Then we are going to get B as the answer. Okay. So here you need to have some changes in this question. So instead of L, he has to ask D. Then you are going to get the answer as 10. Right. Next, sixth one. So already we have discussed about this. So what is the answer? So 2 into capital R square minus small r square. So on comparing this, so what is the big one? So big one is A. So we can write it as 2 into square root of A square minus B square. Hence the answer is 2 into root A square minus B square. Next, in the figure, x is equal to how much? Now if you observe carefully, so since this angle is 60 degrees, then this will be the supplement of 60. So if this is supplement of 60, so what is this angle? So this angle will become 120 degrees. So this angle will become 120 degrees. So if this is 120, then what about this angle? So this angle will become 240. So if the central angle is 240, then angle in the segment will be so half of. So angle in the circumference of the circle will be exactly half of it. So from that, what I can say, x is equal to 240 by 2, which is equal to 120 degrees. Hence the answer is 120. Right. Next, moving on to question number 8. The semi-perimeter of triangle ABC is 28 centimeters. So what is meant by semi-perimeter? So AB plus BC plus CA by 2 is equal to 28 centimeters, right? Now, from the figure, if you observe, this AD length is equal to AF length and BD length is equal to BE length and CE length is equal to CF length. Now, what is he asking you to find? So, AF plus BD plus CE, right? AF plus BD plus CE. So, what is AF here? So, AF I can write it as AD, right? So, AF I can write it as AD. The same way, I can write BD as BE. Next, CE as CF. Now, if I add, then these two will be equal. No? So, let this length be some K and this length is also some K, right? So, when you add these two, so this will be equal to the perimeter, right? So, which is nothing but, so this and this when I add, So what I am going to get? AB plus BC plus CA is equal to 2K. But what is AB plus BC plus CA? So it is nothing but, so AB plus BC plus CA. So it is equal to 2K. Now if I want to bring this 2K here, then what I am going to have? AB plus BC plus CA by 2 is equal to K. Already we have this value as 28 centimeters. From this clearly I can say that K is equal to 28 centimeters. Hence the answer is 28 centimeters. Okay. Next, the length of tangent drawn from a point 8 centimeters away. So 8 centimeters away means clearly he has mentioned the value of D. So D is equal to 8 centimeters and radius is equal to 6 centimeters. So it's asking you to find out length of the tangent. So length of tangent L is given by square root of D square minus R square. Now substituting the values, square root of 8 square minus 6 square. So already we have done this. So this is equal to square root of 28, which is nothing but 2 root 7 centimeters. Hence the answer is 2 root 7 centimeters. Next, in the figure, PQ and PR are the tangents to the circle with center O. Then X is equal to. Now clearly, since this is 70 degrees, this is 70 degrees, then this would be 140 degrees, because if on the circumference angle is 70 degrees, then at the center its angle will be doubled, right? So if it is 70, then this is 140 degrees. So if this is 140 degrees, then this particular angle will be supplement of 140. So supplement of 140 is nothing but 180 minus 140, which is equal to 40 degrees. Hence the value of X is 40 degrees. So clear, the answer is 40 degrees. Next, moving on to question number 11. If you observe this, in the figure, O is the center of the circle and PA, PB are the tangents and their lengths are, so is asking to find out their lengths. So already we know, so from an external point, if a tangent is drawn, if tangents are drawn, then length of those tangents are equal. Now from this figure you can clearly see that it is a right angled triangle in which hypotenuse is 13 and one of the sides is 5. Then using Pythagorean triplet, so we can say that the other side will be 12 centimeters. So if this is 12 centimeters, then this length is also 12 centimeters. Hence the length of the tangents are 12 comma 12 centimeters, right? Next, in the figure, PT is a tangent to the circle with center O, then X is equal to. Now from this figure you can observe that this angle X, so this angle X is nothing but exterior angle of this triangle, right? So from this what we can say, X is equal to 90 degrees plus 42 degrees, so which is equal to 132 degrees. But in the options it is not given. Answer is here 132 degrees. Next, angle in a major segment is. So what is meant by major segment? So in a circle, if we draw a tangent, so if I draw a chord, so if I draw a chord, then the given circle will be divided into two parts, and the part which is having more area is nothing but called as major segment, right? Or simply what we can say, the segment in which the center of the circle exists is nothing but called as major segment. So in major segment, if you consider any angle, so each and every angle in major segment will be acute angle. Hence it is an acute angle. For suppose if it is minor segment, then obtuse angle. If it is semicircle, then right angle. So all these options will be there for each and every condition, right? So this particular part, so this big part is nothing but we call it as major segment, right? So this particular big part is nothing but called as major segment. In the major segment, angle in major segment is always acute angle, right? Next, moving on to question number 14. The length of tangent drawn to a circle with radius r and d units from the center. So already we know this formula, square root of d square minus r square, right? Next, moving on to next question. So here from the figure you can clearly observe that hypotenuse is 25 centimeters and one of the sides is 7 centimeters. Then length of the tangent is given by, so already we know the formula, length of tangent is L is equal to square root of d square minus r square. Now substituting the value, square root of 25 square minus 7 square. So 25 square is 625 minus 49, which is equal to square root of 576. So which is equal to 24 centimeters. Hence the answer is 24 centimeters. Next, 16th question. This question is very important. So PQ is a chord of a circle. So a circle is given. So there is a circle given. So in this circle, PQ is a chord. So what he has given? PQ is a chord. Next, the tangent XR drawn at X meets PQ at R. So meets PQ at R. So if we extend this PQ, so this particular XR, so XR meets at this particular point R. So this X is nothing but the point of contact of the tangent with the circle. Now what he has given, if XR is equal to, so this XR is given as 12 centimeters and PQ is given as X centimeters and QR is given as X minus 2 centimeters. Now if you observe the figure, this XR is nothing but a tangent and PR is nothing but a secant. So when you are having secant and a tangent, then we can apply this formula. So what is the formula? So XR square, that is nothing but length of tangent square is equal to, so product of the segments of the secant, that is nothing but RQ into RP. RQ into RP. Now substituting the values, so this becomes 12 square is equal to RQ value is X minus 2 into RP value is X plus X minus 2, right? So this is 144, which is equal to X minus 2 into, so here X plus X is 2X, so 2X minus 2. Now directly I can take 2 as common, then this becomes X minus 1. So this 2 in 144 I can cancel it out 72 times. So from this 72 is equal to X minus 1 into X minus 2. If you observe, X minus 1 into X minus 2 are two consecutive numbers, right? So here X minus 1 is the bigger one, X minus 2 is the smaller one. So from this I can write it as 9 8s are 72, because we are having 9 8s are 72. So since 9 and 8 are consecutive numbers, which is equal to X minus 1 into X minus 2. Now on comparison, so X minus 1 is equal to 9. So from this X is equal to 10. Or you can compare 8 with X minus 2, then also you are going to get the value of X as 10 centimeters. Right, next moving on to question number 17. So two circles intersect at A comma B. PS and PT are two tangents drawn from P which lies on AB to the two circles. Then, so he is asking you, so what is the relation between PS and PT? Now if you observe carefully, so if you see one figure, so PS and PAB. So if you observe PS and PAB, so already what we have discussed in the previous question. So here one is tangent and one is secant. The same way here, this is tangent and this is secant. So then what I am going to get? So if I apply the same condition, I can write PS square is equal to PA into PB. The same way here also, this is tangent and this is secant. So from that I can say that PT square is equal to again PA into PB. Now since both right hand sides are equal, then we can make left hand sides are also equal. So PS square is equal to PT square. So from this we get PS is equal to PT. Hence the answer is PS is equal to PT. Next in the figure, AB is the diameter and AC is the chord of the circle such that angle BAC is equal to 30 degrees. If DC is a tangent, so if DC is a tangent, then triangle BCD is equal to. Now here the figure is not given. So let us consider the figure. So let this be the circle, and for this circle AB is the diameter. So if AB is the diameter, next what he has given, AC is a chord. So from here there is a chord AC. So AC is a chord. Now this angle formed here is nothing but 30 degrees. Now after this, so CD is a tangent. So CD is a tangent. For suppose if I draw a tangent CD here. Okay, now this particular point D, if it meets my extended diameter, then we can say about triangle BCD. Okay, now we are talking about triangle BCD, right? So this is BCD triangle. Now clearly this angle is 30 degrees. So this is nothing but angle in a semicircle which is equal to 90 degrees. Then this angle will be 60, right? So this angle is 60 degrees. Okay, next, this angle is, so since this angle is 30 degrees by alternate segment theorem, so we can say that this angle is also 30 degrees, right? So this angle is also 30 degrees. Then this angle will be 120 degrees because it is forming a linear pair. Then this angle is 30 degrees. So clearly here two angles are 30 degrees. So we can say that this triangle is an isosceles triangle. So this triangle is called as isosceles triangle. So here he has to mention that D is nothing but a point where it meets the extended diameter. Next, question number 19. If two tangents inclined at an angle of 60 degrees are drawn to a circle of radius 6 centimeters, then the length of each tangent is equal to. Now what he has given? So this is my circle, right? So two tangents are, so there are two tangents drawn. So from a point P, let us consider the two tangents are making 60 degrees angle. So they both are inclined at 60 degrees angle. So if they are inclined at 60 degrees angle, then this each part will be 30 degrees, right? So here it is 90 degrees, this is 30 degrees. Now the radius is 3 centimeters. Now is asking to find out length of tangent. So with respect to this 30 degrees, so this is nothing but adjacent side and this is opposite side, right? So this is opposite side and this is adjacent side. So we can apply tan 30 degrees. So tan 30 degrees is equal to opposite by adjacent. So 3 by L. So tan 30 is 1 by root 3 is equal to 3 by L. So from this L is equal to 3 root 3. Hence the answer is 3 root 3 centimeters. Clear, right? Next, moving on to question number 19. So if two tangents inclined, so already 19 is completed. Next, doing question number 20. So to draw a pair of tangents to a circle which are inclined to each other at an angle of 60 degrees, it is required to draw the tangents at the endpoints of two radii inclined at an angle of. Okay, so what he has given? So he has given a circle and these two tangents are making an angle 60 degrees. Now, so what is asking is, so if two radii are drawn at the endpoints of two, then what is the angle between these two? So what is the angle between the two radii? So already we know if this is 60 degrees, then this will be supplement of 60 degrees, which is nothing but 120 degrees, right? So that the angle between the two radii is 120 degrees. Next, so this is already 3 root 3 previously we have discussed. Now next, the radius of the circle is equal to the sum of the circumferences of two circles of diameter 36 centimeters and 20 centimeters is. Now is asking you to find out the radius of the circle. So radius of the circle is equal to the sum of circumferences of two circles. So here capital R, so let us consider it as capital R. So capital R is equal to 2 pi small r1 plus 2 pi small r2. Okay, so 2 pi small r1 plus 2 pi small r2. So this I can write as 2 into 22 by 7 into r1 plus r2. So if I take 2 pi as common, r1 plus r2. Then since diameter is 36, so its half is 18 plus 20 is half is 10. Okay, so based on this, so what I can say 2 into 22 by 7 into, so 18 plus 10 is 28. So in 7 tables, so this cancels 4 times. Then what I am going to have, the radius of the circle is equal to the sum of circumferences of two circles. Now, so he has to give, I think there is a mistake in the question, right? So for suppose, if I say, so we need to find out the radius, so radius of the circle such that the circumference of this circle is equal to sum of circumferences of remaining two circles. Then what I am going to have, So clearly, so from this we can say that, so on both sides we can take 2 pi as common and we can cancel out. So from this, capital R is equal to small r1 plus small r2. So which gives me small r1 is 18 plus small r2 is, so small r2 is 10. So from this, capital R can be written as 28 centimeters. Right. So here the question has to be given the radius of the circle whose circumference is equal to the sum of the circumferences of. So radius of the circle whose circumference is equal to the sum of the circumference of two circles of diameter, then we can say that its radius will be equal to 28 centimeters. Right. So a small correction in the question. Next, question number 22. If the radii of two concentric circles are 5 centimeters and 13 centimeters, then the length of the chord. So already we know the formula. So 2 into capital R square minus small r square. So directly going with the formula. So 2 into capital R square is 13 square minus small r square is 5 square. So 2 into, so 13 square minus 5 square is 12 square. So 2 into 12, which is equal to 24 centimeters. Hence the answer is 24 centimeters. Right. Next, moving on to question number 23. If tangents PA and PB from point P to a circle with center O are inclined to each other at an angle of 110 degrees. Now drawing the figure. So PA and PB. So this is point A and this is point B. Now O is the center of the circle and these two, so with the center O, are inclined to each other at an angle of 110 degrees. So from this clearly, this is 110 degrees. So this total is 110 degrees. Right. So from that, this particular part is 55 degrees. That is nothing but half of it. And this is 90 degrees already we know. Then what is he asking? Angle PAO. Angle PAO. So angle PAO is 90 degrees. There is no matter of discussing about PAO. So it is not PAO, it is POA. Right. So this angle is angle POA. So if POA angle is asked, then this particular angle POA angle is given by 90 degrees minus 55 degrees. Because this particular angle is 90 degrees, then this will be the complement of this particular angle. So from this, what I am going to have, 90 minus 55 is, so this is 5 and 8 minus 5 is 3. So it is 35 degrees. Okay. Next, in a right angle triangle ABC, right angle at B. So there is a right angle triangle ABC. So right angle at B. Next, what he has given, BC is equal to 15 centimeters, AB is equal to 8 centimeters, and a circle is inscribed inside the triangle. So circle is inscribed inside the triangle. Then, so already we know by using Pythagoras Theorem 8, 15, 17. So this is nothing but the Pythagorean triplet we have. Right now, he is asking you to find out the radius of this particular circle. So the radius of this particular circle is given by, so radius of this particular circle is given by sum of legs minus hypotenuse by 2. So sum of legs minus hypotenuse by 2. So sum of legs minus hypotenuse by 2. So what is sum of legs? So 8 plus 15 minus 17 by 2. So 15 minus 17 is minus 2. 8 minus, so 8 minus 2 is 6. So 6 by 2, which is equal to 3 centimeters. Hence the answer is 3 centimeters. So simply remember this formula. R is equal to, so this in radius is equal to sum of legs minus hypotenuse by 2. This particular circle is called as in circle. Right. Next, how many tangent lines can be drawn to a circle from a point outside the circle? So from outside the circle, we can draw 2 tangents to a given circle. Next, 3 circles are drawn with the vertices of a triangle as centers such that each circle touches the other 2. If the sides of the triangles are 2, 3, 4, find the diameter of the smallest circle. So find the diameter of the smallest circle. So what he has given? So 3 circles of vertices as centers. Now there are 3 circles which are drawn. So all the 3 circles are touching the other two circles. So these are nothing but the vertices. Now, so let us join all these centers. Now what he has given, the sides of the triangle, if the sides of the triangle are 2 centimeters, 3 centimeters and 4 centimeters, so find the diameter of the smaller circle. Okay, now for this what I am going to do is, so let the smaller circle be having the radius x centimeters. Okay, now for suppose, so let suppose the side be 2 centimeters, then this is 2 minus x. So this is 2 minus x. So if this is 2 minus x, this is also 2 minus x, right? Now from this, if this particular side is 4 centimeters, then this is 4 minus x. Sorry. So for suppose, if this is the largest side, so if I say if this is 4 minus x, then this is also 4 minus x, then this particular side will be equal to 3 centimeters. That is nothing but 2 minus x plus 4 minus x is equal to 3 centimeters. So from this what I am going to have, so 6 minus 2x is equal to 3. So from this 2x is equal to, so 2x is equal to 6 minus 3 is 3. Now 2x is equal to 3 centimeters. So what is he asking? The diameter of the smallest circle. So the diameter of smallest circle is nothing but given by 2 times of x, right? Wait, so there is a problem with the question, right? Now let us see once again. So here it did not give any answer 3. Hence let us see once again. So this is one circle and this is another circle and this is the biggest. So this is the second largest circle and this is the third one. So when I take the vertices and if I join them, then two largest will make up the side 4. So two largest circles will make up the sides 4. Now for suppose if this is the smallest circle whose radius is some x. Now this is the smallest side if I consider, then this is 2 minus x, and if this is the, so this is the next smallest, then this is 3 minus x. Now since this is 3 minus x, so this also will be 3 minus x and this is 2 minus x. Now since these two are big circles, then this side length will be equal to 4. So from that what I can say, so 3 minus x plus 2 minus x is equal to 4 centimeters. So based on this, so 5 minus 2x is equal to 4. So from this 2x is equal to 1. Here since x is nothing but the radius of the given small circle, then 2x is nothing but the diameter. So he is asking you to find out diameter, hence the diameter is 1 centimeter. Right, so in the previous one, so we have taken that particular configuration as wrong. So that's why we got wrong answer here. So whenever you are having a longest side, that means you need to consider two big circles. Okay. Next, moving on to question number 27. A circle may have dash parallel tangents at most. So it will have at most two parallel tangents. Now these all are theoretical questions. A tangent to a circle intersects it in dash points. So tangent intersects at only one point. Next, a line segment joining any point on the circle is called its. So a line segment joining any points on the circle is called its chord, right? So line segment joining any 2 points on a circle. So any 2 points on a circle is called as chord. So here, so this is the mistake, right? So here it should be any 2 points. So then we can say that it is a chord. Next, a line which intersects the given circle at two distinct points is called as. So it is nothing but called as secant. Next, the common point to a tangent and a circle is nothing but called as point of contact. Next, angle between tangent and radius drawn to the point of contact is 90 degrees. Right? Next, question number 33. The circumference of the circle is 100 centimeters. So 2 pi r is given as 100 centimeters. Next, the side of a square inscribed inside the circle is. The side of a square inscribed inside the circle is. So from this radius is given as, so 50 by pi. right? So when you take radius, it is 50 by pi. Now what is he asking? So inside the circle, a square is inscribed. So inside a circle, a square is inscribed. So this is a square. So this square is inscribed inside a circle. Then what we can say, diameter of the circle is equal to, so what we can say, diameter of circle is equal to diagonal of square. So from this clearly you can observe from the figure, diameter of circle is equal to diagonal of square. So what is diameter of circle? So diameter of circle is nothing but 2r. So 2r I can directly write it as 100 by pi. Sorry, 100 by, right? So r is equal to 100 by pi. So diameter of circle is 100 by pi, which is equal to diagonal of square. So diagonal of square is nothing but root 2 times of the side. So from this I can write a is equal to 100 by root 2 into pi. Now again this 100 I can write it as 50 into 2. Again 2 can be written as root 2 into root 2. So 1 root 2, 1 root 2 I can cancel it out. So from this I am going to get 50 root 2 by pi. Hence the answer is 50 root 2 by pi. So likewise we can find out. Next, the area of the square inscribed in a circle of radius 8 centimeters. Just now we said, so diameter. So 2 times of radius is equal to root 2 times of a. Right? Now squaring it on both sides. So we are going to have 4r square is equal to 2 into a square. Since I need the value of a square. So this is 2 in 4, it cancels 2 times. So 2 into 8 square. So 8 square is 16, 16 2 sir. Sorry, 8 square is 64, 64 2 sir, 128. Hence the answer is 128. So which is nothing but a square. So a square is equal to 128 centimeter square. So likewise we can do it. Next, the area of the circle that can be inscribed in a square. So now the situation is reversed. So inside a square we are going to inscribe a circle. So from this what we can say, so in this particular situation, diameter is equal to side of square. So diameter is equal to side of square. Then what is he asking? Area of circle. So first of all, what is diameter? So diameter is nothing but 2 times of radius is equal to side of square. So already side of square is given as 6 centimeters. Now from this, what is radius? So radius is equal to 3 centimeters. Now area of circle. So area of circle is given by pi r square. So r square means, so 3 square 9. So it is 9 pi centimeter square. So the answer is 9 pi centimeter square. Hence answer is A. Next, the perimeter of a quadrant of a circle of radius 7 by 2 centimeters is. Now perimeter of quadrant circle. So perimeter of quadrant circle is given by pi r by 2 plus 2r. Pi r by 2 plus 2r. Now substituting the values, this is pi is 22 by 7. Sorry, 22 by 7 into radius is 7 by 2. So 7 by 2 into, already by 2 is there, so that 1 by 2 plus 2 times of r is again 7 by 2. Now cancellations, so 7 7 gets cancelled, in 2 table this goes 11 times and this 2 2 will get cancelled. So here 11 by 2 is nothing but 5.5 plus 7. So 7 plus 5 is 12, so this gives me 12.5. Hence the answer is 12.5. Next, the number of tangents at one point of a circle is. So at a particular point, how many tangents we can draw? So passing through a point, so we can draw only one tangent. Number of tangents to a circle which are parallel to a secant are. So parallel to a secant, so we can draw only two tangents, right? So parallel to a secant, so we can draw two tangents, because so for a tangent, so we can draw one parallel tangent, right? So if I consider like that, then we are going to have two tangents which are parallel to a given secant. Next, question number 39. Dash tangent can be drawn from a point inside the circle. So no tangents can be drawn from a point which is inside the circle. Next, a tangent to a circle is a line which dash the circle exactly at one point. So which touches the circle at exactly one point. A line which is perpendicular to the radius of the circle through the point of contact is called. So the line which is perpendicular to the radius of the circle. So it is nothing but called as tangent. Next, the tangents drawn at the ends of the diameter are. So they are parallel. The tangents drawn at the end points of the diameter are parallel. Next, the tangents drawn at the end point of radius is. The tangent drawn at the end point of the radius is perpendicular to the radius. Right? Next, tangents drawn from exterior point are equal. The tangents drawn from exterior point are equal. Next, a secant meets a circle in dash points. So secants meet a circle in 2 points. Next, a tangent meets a circle in 1 point. Next, sum of central angles in a circle. So what is the angles at the center of the circle is nothing but 360 degrees. Next, angle in a semicircle at the center. So this point is important. So angle in a semicircle, if he says it is 90 degrees. Now here he is asking at the center, hence it is 180 degrees. Now next, from the figure, x is equal to dash centimeters. Now here PA is 4.8 centimeters, then PB is also 4.8 centimeters. Hence answer is 4.8 centimeters, because length of tangents drawn from exterior point are equal. Next, angle in a semicircle is. So angle in a semicircle is 90 degrees. So these two things you need to understand. Right? So angle in a semicircle at the center is 180 degrees. Angle in a semicircle is 90 degrees. Right? Next, moving on to question number 51. In the figure, P is called. So here this P should be small p. Right? So this particular P is nothing but a line. So since it is meeting the circle at two distinct points, we call it as a secant. Right? So number of tangents drawn to a circle is. So to a circle, how many tangents we can draw? So we can draw infinite tangents. If it is from exterior point, then only two are possible. Right? Next, in the figure, angle AOB. Angle AOB. So it is absolute blunder. So it should be angle OAB. Okay. It should be angle OAB. So then it is 90 degrees. Right. So this is radius and this is tangent. So tangent and radius will be perpendicular to each other at point of contact. Okay. So it should be given as OAB. Next, in the figure, x is equal to how much? Now clearly you can see that from this figure. So one side is 3 and the other side is 4. This is hypotenuse. Right. So 3, 4, 5 is the Pythagorean triplet. So using that we can say that answer is 5. Next, angle in a minor segment is. So minor segment means, so in a circle if we draw a chord, then the part which is having lesser area is nothing but called as minor segment. So in the minor segment, if we consider the angle, so this angle will be always obtuse angle. Right? So from this what we can say? So what we can say here, so angle in the minor segment is always obtuse. Right? So these are the questions, multiple choice type questions related to the chapter secants and tangents to a circle, and we are going to discuss some more questions in the next video. So stay connected to the channel, and if you are new to this channel, so please subscribe the channel and share with your friends. Right? So thank you for watching.